Hello everyone, I am Dr. Praveen Chandra Jagtap. I am working as an assistant professor in Department of Chemistry, MSP Mandras, Sri Shivaji College, Parbhani. This college is affiliated to Swami Ramananda Tirtha Marathwada University, Nanded. In today's lecture, we are going to learn about key concepts, criteria, and examples regarding aromaticity and antiaromaticity. Firstly, we are going to learn about aromaticity. Aromaticity is nothing but it is a property of organic compounds which are cyclic planar molecules with continuous delocalization of pi and non-bonded electrons, which provides extra stability to the compound. The aromatic compounds must follow four conditions that are nothing but first one is it must be cyclic in nature, the structure should be planar, there must be continuous delocalization of whatever pi and n electrons present in the structure, and also it must follow Huckel rule, that is 4n plus 2 pi electron rule, where n is nothing but integer. Characteristics of aromatic compounds are nothing but they are highly stable than their isomers. There is delocalized electron cloud and the bond length are equal in all resonating structures. The example is the very basic example is there, that is nothing but benzene. We all know structure of benzene. Benzene is nothing but six membered aromatic ring. Whatever three pi bonds are there, they are fully conjugated. Moreover to this, the structure is cyclic and planar. And if we put n is equal to 1 in 4n plus 2 pi electron rule, that is Huckel rule, we are getting 6 pi electrons, and that number is exactly matching with our 6 pi electrons present in benzene. That's why benzene is aromatic compound. The next example is naphthalene. As we see, there are 5 pi bonds. it it fulfills all four conditions. The structure is again cyclic, planar, every carbon is sp2 hybridizer. There are 5 pi bonds means 10 pi electrons, and if we put n is equal to 2 in 4n plus 2 pi electron rule, we are getting exact number, that is 10 pi electrons. That's why naphthalene is also aromatic in nature. Next compounds are nothing but anti-aromatic compounds. As far as anti-aromatic compounds are concerned, the first three conditions are exactly similar to that of aromatic compounds, but there is difference in fourth rule. The first three conditions are that anti-aromatic compounds are again cyclic compounds, their structures are also planar, whatever may be pi electrons and n electrons present in compound, they are must again fully conjugated, there must be continuous delocalization of that electrons, but moreover to that, that compound must follow 4n pi electron rule instead of 4n plus 2 pi electron Huckel rule. Due to this reason, due to only this difference, these compounds are unstable as compared to aromatic compounds. As we discussed, the criteria are the compound must be cyclic, planar, there must be fully conjugated system, and must contain 4n pi electrons, where if we put n is equal to 1, 2, we are getting 4, 8, 12 like numbers, and that much pi electrons or conjugated electrons must present in our compound. we see about characteristics of antiaromatic compounds. As compared to aromatic compounds, as we discussed earlier, these compounds are highly unstable and highly reactive. Examples of antiaromatic compounds. First example is cyclobutadiene. As we see in structure, the cyclobutadiene is four-membered carbocyclic ring in which two pi bonds are there which are fully conjugated. That means this compound is planar, cyclic, and having delocalization of pi electrons. But the total number of pi electrons which are conjugated is 4 pi electrons. That's why this compound is following 4n pi electron rule. That's why we can say that cyclobutadiene is anti-aromatic in nature. The next example is cyclooctatetraene. As we see, cyclooctatetraene is again planar and cyclic compound. Moreover, there are 4 pi bonds which are completely conjugated with each other. But we can say that it follows 4n pi rule. If we put n is equal to 4 in 4n pi electron rule, we are getting 4 into 4, 16 pi electrons. That's why we can say that this compound is anti-aromatic in nature. If any compound is not fulfilling any one criteria from first three criteria, then that compound is non-aromatic in nature. Means if compound is lack of planarity, if the compound is not having all carbon atoms sp2 or sp hybridized, or if the compound is not having continuous delocalization of pi and n electrons, that compounds falls in the category of non-aromatic compounds. We can again derive the stability order amongst aromatic, anti-aromatic and non-aromatic compounds, as aromatic compounds are more stable than non-aromatic compounds and non-aromatic compounds are more stable than anti-aromatic compounds. This is all about aromatic and anti-aromatic compounds. Thank you.